Hello again. Now that you have gotten to the point where you know your GitHub Action workflows very well, you are able to easily create your CI/CD workflows and deploy to production. You're quite familiar with a lot of different cloud services. Now comes the time where you need to learn how to deploy securely to the cloud and how you can eliminate the headache of having to manage and configure credentials and secrets on GitHub and all of the operational pains that come with that. In this video, we're going to be talking about OpenID Connect. We're going to talk about what it is, how you can configure it, how does it work behind the scenes, and I'm going to be showing you a live demo of how we can reconfigure our continuous deployment workflow from previous episodes to leverage OpenID Connect so that we can deploy more securely. The demo and all of the juicy details are coming up next. Stick around. So let's break this down a little bit and show you what we're going to be building in this video and how we're going to get there. On the left hand side, you will see we have the CI/CD intro repository. This is a normal GitHub repository, nothing changed there. We used it in previous demos and we're going to continue using it in this one. The only change we're going to introduce is we're going to create a new workflow file, which we're going to call cd-oidc.yaml. OIDC stands for OpenID Connect, as I mentioned previously. In this workflow, we're going to use pretty much the same structure. Not much is going to change. We're going to define a deploy job. We're going to give it a name. And then we're going to define a couple of steps. First one is going to be the retrieval of the credentials. And I'm going to explain a little bit why we need this step and what really happens in this step. And the second one is simply deploying our application to our target. On the right hand side, you will see we are also deploying to AWS this time. And instead of deploying to our virtual machine, which we did in previous episodes, today we're going to be actually deploying to Elastic Beanstalk. And Elastic Beanstalk is pretty much a managed service provided by AWS. There's a similar service to it in Azure called App Service, for example. I'm pretty sure there's something quite similar to it in Google Cloud Platform. I'm using Elastic Beanstalk today just for convenience and for simplicity because I don't really want to recreate an entire environment. I don't want to deploy to a Kubernetes cluster. All of these options are feasible, but for this simple web service, Elastic Beanstalk should be more than enough. The added value of Elastic Beanstalk is also the ability to automatically scale and handle additional loads as they come in. We're not going to be using any of these advanced features. We're just going to be relying on the basic features of Elastic Beanstalk. Now, the main differences about how we're deploying today. In a previous episode, I showed you that in order for us to actually deploy to a virtual machine, we needed SSH keys. We maybe needed other types of credentials that we needed to store as secrets on our GitHub repository. In this demo and using OpenID Connect, we will not need secrets at all. So no more secrets. And this is the beauty of OpenID Connect. It's going to allow you to deploy and utilize services on the cloud provider end without necessarily requiring any secrets to be stored on the GitHub end. And this also eliminates all the future operational problems of rotating secrets, the headaches of secrets being compromised, and all of the nasty stuff that comes from having to manage passwords or API keys or anything of that sort. Now, how does this all work? This works because GitHub has done a partnership with different cloud providers, and in this case AWS, but also we have done it with Azure and Google Cloud that will allow the cloud provider to authenticate any request that comes from the GitHub side against what we call trust policies. I'm saying too much, but let me explain in this diagram. So everything starts with this basic step over here. And in this step, we are simply asking AWS, in this case, to provide us with an access token that will allow us to make changes or introduce changes to services that are owned by some specific account. And how does that happen? We are going to ask for a specific role to assume on the AWS side. If you are familiar with identity and access management on AWS, roles allow you to define specific policies and permissions that a certain entity, or in this case that GitHub, or in this particular case a workflow, can assume, and the roles will create the boundaries beyond which you cannot really do much on other services. This is very important for security purposes, and the roles should be restricted to as little permissions as possible. And then we're going to ask for a specific session name. We're going to provide a session name. That's fine. We're going to provide an AWS region. This is all that is necessary for our workflow to request an access token from the cloud provider in this case. Now, this information is going to be taken along with other information as well. And GitHub is going to create what we call a JSON web token. This JWT will contain information like, for example, the repository name. It will contain the branch name from which we are trying to run this workflow. It will contain information about the owner of the repository, like, for example, if it's coming from an organization or a user, so on and so forth. And it will also contain a bunch of other relevant information for the cloud provider to authenticate, that whoever is requesting these permissions actually has the right to get an access token based on this information. Now, this JWT, of course, is encrypted with keys that are, private to GitHub, and also another key that is shared with the cloud provider so that they can decrypt the JWT and actually see the content of it, right? These keys are not shared with anyone, just so that we can make sure or guarantee the security of the payload. Now, once this JWT is created, it is obviously transmitted to AWS over the internet, and it goes to the identity and access management service where the JWT is decrypted and validated, and the content of the JWT is compared against what we call a trust policy. In this trust policy, we will define the criteria with which we can validate and say, okay, this specific repository, this specific workflow, they have access to what they claim, they have access to. And once AWS validates this claim, it will generate an access token that has a lifetime of 1 hour, and then it will return this access token back to the OIDC service on the GitHub side, and then this access token will be made available for our workflow. And once this access token has been made available to our workflow, this specific action, which is called the configure AWS credentials action, will actually take these credentials or access token, and it will configure our machine so that we can leverage or utilize the AWS CLI, for example, or maybe other actions so that we can make changes on the cloud provider front. And in this case, we're going to be using a utility, a CLI utility provided by AWS themselves. It's called the Elastic Beanstalk CLI. I'm going to show you how you can install it and how you can use it. And we're going to use this Elastic Beanstalk CLI to deploy our application. We will not need to configure anything. We will not need to add any more secrets. That's it. That's all the authentication authorization mechanism has happened. And in this case, this CLI tool will have access to the authentic access token. And by calling this command, we will actually be able to deploy our service through the internet directly to Elastic Beanstalk from the content of the branch that we are trying to actually deploy. And this is it. It's quite simple, to be honest. Everything is happening magically in the background. You won't have to worry much about what's going on. The GitHub and the cloud provider will do all of the security, encryption, decryption, authentication stuff that is necessary. All you need to do is to configure OIDC to work, and I'm going to show you how to do that next. And then from there, you can pretty much do whatever you need to do on the cloud provider front, as long as you specify the specific role that has the access necessary for you to introduce these changes. So enough with the theoretical, let's actually get going with our setup. First thing we're going to do is we're going to check that our GitHub CLI is actually properly authenticated, and it is. Then we are going to clone our repository locally with gh-repo clone, and the repository is called CI/CD intro. And then now that we have a local copy of this repository, we're going to go in and check it out. You're pretty much familiar with this from previous episodes. We use the infra folder for our infrastructure and Terraform setup. And then we have our web application inside the web folder. Let's actually go into the web folder because we're going to be doing our changes over here. Next, I'm going to do a small trial to see if this small web server is working. Let's get our trusted tmux up and running, and then we're going to do an npm start. Let's start a new window, and then we can do a simple curl -g http localhost, and I think this runs on the port 3000 by default. yes, we got our expected response, and you can see here that the request actually came to the web application. That's great. This all looks good to me. So now we are gonna be setting up our application so that we can deploy it to Elastic Beanstalk. We need to introduce a few changes to our package.json, and one of the changes is we need to specify which node version we would like to be using with Elastic Beanstalk. So we're gonna open our package.json, and you can already see here that I have added the engine to be higher or equal to node version 16. This is important because Elastic Beanstalk is going to set up the environment based on our requirements over here, and it's going to install the node version that is actually required by our application. This is the first change. So once you introduce this change to your package.json file, or if you have cloned the repository as it is, the change should already be there. The next thing we're going to be doing is we're going to be creating something called a proc file. And the proc file is necessary because this is what's going to tell Elastic Beanstalk what is the starting command of this web server. And the proc file doesn't need to contain much. It just needs to contain node and then the path for whatever script we're going to be running, right? So why are we using this? Because when we call, if you look at the content of package.json, you see that we have defined a script over here, which is called start, right? When we called npm start, this is the command that we are actually invoking, node, and then we, start the www file. This is what we need to do. So now that we have these files, the package.json edited and the proc file created, I think we are now ready to deploy this on Elastic Beanstalk. So first of all, we need to make sure that our AWS CLI is installed. You can do that with Brew or whatever other package manager you want, or there's a manual way for you to install AWS CLI. You're gonna need it because this is how you're gonna be authenticating, first of all, from your terminal to AWS. Once you install AWS CLI, you need to run AWS configure, and this is where you can provide the API key. I'm gonna be access key, sorry, and then I'm gonna be providing the secret access key. I'm gonna be revoking those. So now that they have been exposed, and then I'm gonna be using the region EU West 2 and default output format. I don't care at this point. Once I provide these two credentials, and you can create these credentials from your AWS IAM. We're not gonna go through that right now. I'm gonna assume you already know how to do this. And then what we're gonna do is we're gonna install AWS Elastic Beanstalk CLI. It's feasible for us to deploy using the AWS CLI to Elastic Beanstalk. However, the API is very, very raw, and it's a bit complex to do it. It's fine for scripting, but it's not nice for a user experience. That's why we're going to download the Elastic Beanstalk CLI, because it encapsulates and it abstracts a lot of the stuff that we needed to do with the AWS CLI. So let us install it using Homebrew. And in the meantime, I'm going to go to my AWS console. You can see here, this is my identity and access management dashboard. I told you before, you can create a user. I created a user called AWS CLI. This is where I got my access key and access secret key that I use with the AWS configuration or AWS configure command, right? We're going to be spending a bit of time here to configure our OIDC, which we're going to be using in the next steps. But for now, let us also go to the Elastic Beanstalk service. And in the Elastic Beanstalk, you can see that I currently don't have any environments set up, and I don't have any applications configured. We're going to be doing that right now with a few commands as soon as our Elastic Beanstalk CLI is installed. And as you can see, it's already done and configured. The next step is for us to create an Elastic Beanstalk environment, and we can do this very simply with Elastic Beanstalk initialize -i for interactive, and this will allow us to specify different parameters, like for example configuring the region. I'm going to be using the London region for this demo, and then I'm going to be providing the application name. I'm going to be calling it CI/CD intro. You can call it whatever you want, and it appears that I'm using Node.js. That's great. Yes, that's correct. And then I'm going to specify which platform branch I'm going to be using. I'm obviously going to go for Node.js 16, so I'm going to go for number 1. And I'm not using code commit here. So, and it's actually asking me if I want to set up SSH for my instance. Yes, this is helpful when you want to troubleshoot things that are going wrong with your server. So I'm gonna actually ask it to set up SSH. It's going to ask you whether you use an existing key pair or it's going to create a new key pair. I already created an existing key pair, so I'm going to be using that. If you want to create a new SSH key pair, you're free to do so. Now that I have my environment configured, we need to create a sample application. And we create a sample application because it's already configured for us. So we don't need to do much configuration over here because the purpose of the video is not to talk a lot about Elastic Beanstalk, but OIDC. This is all necessary for our demo, but still, I'm not going to go in depth into it right now, maybe in future videos. So I'm going to create a new sample application, obviously called CI/CD intro, and we're going to wait for Elastic Beanstalk to actually set it up in our environment that we just created. Obviously, the Elastic Beanstalk environment is not just a container or a VM. It's a VM. It's also a load balancer. It's a security group. And it's going to create an S3 bucket where it's going to contain the code base of our application. So it's a bunch of stuff that are created in the background for us. We don't have to worry how these things work together. If you know, perfect. If you don't, all the magic happens by Elastic Beanstalk and you don't have to worry too much about it. Fantastic. Now that our environment and application have been created, we can actually go to our AWS console, refresh, and we will be able to see both of them configured. So let's go to our environments. You can see the CI/CD intro, the health is okay, everything is fine. And what we have actually deployed is a sample application that comes from AWS. So you can see under the URL, if you click on it and go to the browser, you will see that our environment is up and running. This obviously is not hosting our web application, which we're going to change that right away. But it's a quick way for you to do a quick sanity check and make sure that your environment is up and running as necessary. And this is the application that we have just created inside our environment. Now is the time for us to deploy our application. However, before we do that, we need to make sure that our Git repository is in a good state. So we run git status and we see we have a few files that we need to stage. It's important for us to stage and commit these files before running EB deploy because that's how Elastic Beanstalk likes to operate. So we're going to stage these files and then we're going to commit them. Prepare environment for EB deployment. And then once we commit these changes, we don't need to push them upstream. We can just run EB deploy. And what this will do is it's going to create a tar file or a zip file of an archive basically of our web app. And it's going to push that or upload it to our S3 bucket. And from there, it's going to deploy it to our environment in the VM that Elastic Beanstalk has created. And it's going to make it available for us to use. As you can see here, right now the environment is being updated. And the way Elastic Beanstalk works is quite nice. If you SSH into the VM, you'll notice that in the application directory, you will have two folders. One is called staging and one is called current. So the old application is going to stay up and running all the way until the new application has been successfully deployed and made up and running. So it's sort of a blue-green type of deployment on Elastic Beanstalk, and it's actually quite nice if you want to deploy new instances or new versions of your application without worrying too much about what's happening. So as you can see here, the deployment has been successful, and we can verify this with a couple of ways. First is by calling EB logs. We can fetch the logs from our application and see if we have any errors, issues, whatever is popping up. And the next way is, of course, to do a quick smoke test and check it in the browser. So you can see here from our application's standard output, the server is running, everything looks good. From the engine, we don't see any errors. This is all debugging information. Access logs and error logs are clean, so everything looks fine on this end. Let us close it and let's go to our browser. We already have this up and running, so we're going to refresh the page, and you can see we have the Nimble Ice simple Express or Node.js Express application or web server up and running. We had another endpoint which is called Iceflakes. Let us run that. This should return a JSON output. Perfect. That's exactly what I wanted to see, which means that our application has been successfully deployed for the first time. This is necessary for us to create the continuous deployment pipeline. It's for us to manually deploy this application for the first time. Next iteration is going to be automatically deployed with our workflow. Let us see how we can make that happen. Now, let us configure OpenID Connect. Let's go to our AWS console. Let's switch to our security credentials screen, which is the identity and access management. The first thing we're going to be doing is we're going to go to the identity providers tab over here on the left. Now that we are in the identity providers view, we're going to click on add provider, and then we are going to be clicking on OpenID Connect. Now, where are you going to be able to fetch this provider URL? It's very simple. You go to our GitHub documentation, and I'm going to be dropping the link for that in the description below. It's very simple. The configuration for AWS is already provided for you. So you just need to copy the provider URL from here and paste it in this input field. And then you need to get the thumbprint for this provider. Next, you need to fetch the audience, you need to provide the audience, which is sts.amazonaws.com. And then you can add tags. They're optional. Once you have many providers in your account, you might want to add tags to make it easier to manage them and identify them. Next, you click on add provider, and that's it. You just added GitHub as a new OpenID Connect provider. The next thing we're going to be doing is we're going to be creating a new role that is going to be used, or that's our workflow is going to assume, because we said we want the role to be narrow and restrictive. We don't want our workflow to be able to do everything on our platform. So we're going to be creating the role right now, and then we're going to be configuring our trust policy. So I'm going to be creating I'm going to be clicking on the create role button, and then I'm going to select web identity, and then I'm going to be picking the provider, and the provider in this case is going to be GitHub, which is the token.actions.github user content, and then I'm going to select the audience as well. Next, I'm going to click on next, and then we're going to be adding the different permissions, right? This is where you need to provide specifically what the workflow requires. I am lazy, so I'm sorry, this is not really good practice. So I'm going to give it like full admin privileges for now, just because I want to move forward quickly, and I don't want to go through the exercise of identifying exactly the permissions required. So I'm just going to give it full admin access. You don't need to do that. You need to be way more restrictive, but this is a sample setup for me, which I'm going to destroy after this whole video is done. Next, I'm going to give this role a name. I'm going to call this OIDC link EB deployment, for example, and I'm going to give it a description, link CI/CD intro Elastic Beanstalk deployment role, right? Be as descriptive as possible. You're gonna need it. The selected trust entity, this is it by default. We're gonna modify this in the next step, but first let us create the role. Perfect. Now that the role has been created, you can see it here in our list. I'm gonna click on it, and you can see this is the ARN for the role, which we're gonna be using in our workflow in a bit. We have administrative privileges, which is again very bad practice, but for now let's just go with the flow. Next is our trust relationship, and here we're gonna edit the trust relationship, because right now the trust relationship is only looking at the AUD field in our JWT token. If you want to see what are all of the fields that are contained in our JWT token, you can actually go to our documentation one more time. And if you scroll down, this is all of the content of our JSON web token. And you can see here we have the sub, which contains the repository owner, as well as the repository name, the environment that we're going to probably be using, the AUD, which is pretty much the reference to the GitHub organization or user owner of the repo, the ref, which is going to be the branch we're going to be deploying from, a bunch of other claims, right, which we can have certain rules to check against. Now, we're going to add a couple of tests or conditions to our trust policy, and let's click on edit trust policy to add these changes. What we're going to be, the changes that are going to be introduced are going to be on the condition level. First of all, this here, it says string equals. I'm going to change that to make it string like, because I want to compare not necessarily, a full one-to-one equality. I want to add a wildcard over here for my next condition. And the next condition is going to be the sub, right? I want to check the sub, and I want to make sure that I'm able to deploy from this specific repository. However, I don't want to configure the branch that I'm deploying from. I want to be able to deploy from any branch, from any environment. Of course, it's ideal for you to specify exactly the environment you want to deploy from, and maybe even specify the branch you'd like to deploy to production from. For now, I want to keep things simple for me, so this is why I'm using this wildcard. I'm gonna drop a link in the description also for all of the potential options that you can use over here. But for now, this is gonna be my configuration. Of course, you can be more specific and you can say ref, and then you can specify whichever branch you want to use. So for example, if you want to use the main branch, you can say something like this, and this will only allow the main branch to utilize or assume this role and then deploy to Elastic Beanstalk. But I don't want that for my current demo, so I'm gonna skip it and I'm gonna use a wildcard. I'm gonna click on update policy, and then once the policy has been updated, this is pretty much it. This is OIDC, it's configured, and now what I need to do is I need to add a workflow to my repository, and from there I can actually deploy my application from the repository and from GitHub Actions as many times as I want. Let us create our OIDC deployment workflow. Let us go to the .github/workflows, and we're just gonna create a new file, and we're gonna call it OIDC, or let's call it cd-oidc.yaml. And inside this new workflow file, we're gonna be adding our new continuous deployment workflow, which is gonna be leveraging OIDC. I'm copying this workflow from existing work that I have, but I'm gonna be explaining what's happening. So nothing really out of the ordinary here. We're just specifying the events. Whenever a push is introduced on the main branch, specifically whenever changes are introduced inside the web folder, we're gonna trigger this workflow. We can also trigger this workflow manually. Next, we're gonna be specifying the permissions for the token. And because we are using OpenID Connect, we want to specify the ID token permission to write. And then we're gonna be specifying the content permission to read, because I want to create a clone of this repository on the runner itself. Next, we have the deploy to production job. And I'm gonna be using the normal production environment as you've seen in previous videos. If you don't know what's happening over here, I highly recommend that you check the previous episodes. I'm gonna drop a link for that also in the description. Then we're gonna be running on Ubuntu latest, nothing really out of the ordinary. However, over here, we have the step where we fetch the configure AWS credentials, right? And here we have to introduce a couple of changes. First change is on the level of the role that we're gonna be assuming. And we are gonna go to our AWS console. We're gonna be copying the ARN from here, right? And then we're gonna be dropping that here and saving the file. It doesn't matter what you give the session name. I'm gonna be calling it Elastic Beanstalk deployment. And of course, the region is EU West. Next, we're gonna deploy the changes. So we're gonna be using shell commands for that. Obviously, AWS EBCLI is not installed on the runner, so we're gonna have to install it first before we can actually use it. And then we're gonna call ebdeploy. How does ebdeploy know what it needs to deploy and where it needs to deploy it from? You remember the Elastic Beanstalk configuration file over here? This is how it's gonna know. It has the environment name, it has the application name, and once this action configures the credentials on our runner, the ebdeploy is gonna go to AWS. It's gonna fetch an access token based on the claims from the JWT token or from the JWT that has been created. And once AWS says, yes, you already have that permission to deploy, it's gonna assume this particular role, and then it's gonna allow us to deploy our application to Elastic Beanstalk. That's it, that's all we have to do. I'm gonna save this file. Obviously, I'm gonna commit this. I'm gonna push these changes upstream to my repository. Now, if we go to our repository over here, you will see these changes have been pushed to my main branch. And if I go to my actions tab, you will see that I have the add OIDC deployment workflow already triggered, and it's waiting for my approval, obviously, because we're deploying to production, right? So I'm gonna go to my other account, I'm gonna go to the actions tab, and I'm gonna provide the approval for this deployment. Allowed for testing, I'm gonna approve it, and then we're gonna go back to this account over here. You will see that this deployment has been approved. And then if I click on the details, let's see what's gonna happen over here. And as you can see, it happens fairly quickly. So the repository has been cloned on the runner. The configuration of the AWS credentials has been done successfully. We were able to successfully fetch the access token. Next, we are installing the AWS Elastic Beanstalk CLI. I know this is wasteful. Just humor me here for this small demo. Obviously, there are many better ways to do this. Instead of installing the EB CLI over and over again, you can, for example, configure a self-hosted runner that already has this pre-installed on it, and then you can use that self-hosted runner for, you know, deploying to Elastic Beanstalk. Or what you can do is maybe, I don't know, like download the binary for Elastic Beanstalk CLI directly instead of using Homebrew, for example, which will include all of the other dependencies, so you can package it in a different way. Or maybe you can figure out how you can do that with the AWS CLI, and instead of using the Elastic Beanstalk CLI, you can do it from the AWS CLI, which already comes pre-bundled or pre-installed on the GitHub hosted runners. It looks like we have a small issue here. It says that this directory has not been set up. I don't think that's totally correct. So let us verify what's happening over here. It looks like the Elastic Beanstalk file has not been pushed for some reason, and it has been ignored. So let me change this. I think the git ignore file is actually ignoring this. Let me make this change. All right, this is the issue over here. So I'm gonna remove the Elastic Beanstalk files, obviously because I want this to be pushed to my repository. And let's just make sure that our configuration file can actually be staged right now. So let's see if there are other instances. Doesn't look like it. Maybe I have another git ignore. Yeah, there it is. So let us remove these over here. And then now Elastic Beanstalk file can actually be added. So let us introduce these changes. Fix git ignore. And let us again push these changes to our upstream repository. Now, once we did that, we can actually go back and have another go at this. Let me approve it one more time. And while we do that, let us actually verify that the changes have been pushed. And yes, that's correct. The .elastic beanstalk folder and file has now been pushed upstream. So this should work, hopefully, crossing fingers. Perfect. And it looks like our deployment has been successful and everything looks great. If you look at the details over here, we can see that the new environment update has been successful. Now I'm gonna introduce a small API change. We're gonna run this workflow. We're gonna actually see the API change reflected in our application. So let us do that. Fantastic. Let's go back to our editor and let's open the routes folder. Let's go to the index.js. And in this case, we have this endpoint called ice flakes. Let us maybe change this count to become 1005. And then instead of shape, we say instead of circle, we say rectangle, right? This is a very simple change. Let's go to the browser, see our current state. So the current state says count 300 and shape is circle. That's great. This is a change we want to see. Let's change this update response of ice-flakes. And then again, let's push these changes upstream. And once that is done, our workflow will automatically be triggered to deploy these changes. Sorry, not this window. Our workflow is automatically going to be triggered to deploy these changes to production. And if you go to the Actions tab, you will see here that I have, my workflow pending. Obviously, this should happen through a pull request, and then the pull request should be approved before the deployment to production happens. But right now, we're going to skip all of that stuff because I want to show you, the real thing without wasting a lot of time. We're gonna go to the Actions tab, and one more time we're gonna approve these changes. So I'm gonna approve them. It's gonna take probably a couple of minutes before these changes are reflected. So what we're gonna do is we're gonna go here and we're gonna do a curl so we can test it from our and then we provide the endpoint over here, and now every 3 seconds the endpoint is going to be called, and then this is where we're going to be getting the response. So once the deployment is complete, we should immediately see this response change to whatever we expect it to be, and let us see when that will happen. Let us also have the workflow running side by side. Great, we're still in the process of installing EBCLI. This is what I told you about the process being a bit wasteful. And if you notice, even though we are deploying the application right now, the API endpoint has not gone down. So this is sort of the cool part about the blue-green type of deployment. And you can see immediately the change has been reflected, and our response has now changed to become 1005 and shape to be rectangle. And of course, we see here that the environment has been updated successfully, and our workflow ran and completed without failure. That's it. That's all I wanted to talk about today. I hope you enjoyed this demo. I know I tend to go a little bit beyond the topic of choice, but I really want to show you a lot of different things in a very short amount of time. And I really hope that you get some interesting insights and information and new tips and tricks from these videos. If you like this, I don't need to remind you, feel free to subscribe to this channel for more awesome content. I have probably 1 or 2 more videos in this GitHub Actions course, and then I will be completing it. It's taking a lot of time, I know, but life happens. So until next time, I want to wish you all the best. Thank you very much for watching.